Thank you. Thanks,
Okay, Dave. Over to you. Thanks very much.
Right, good afternoon all. I realise it's only me and 19 slides that are between you and dinner. Why am I stood here? I'm not, as has been said, I'm not really a satellite person, but there again, perhaps I am. My background, I started doing amateur TV on 405 lines. First received TV from a geostationary satellite 30 years ago with Noel and I worked together on that. First did digital ATV testing about 15 years ago terrestrially. And built my own receiver for Tim Peake's ISS video as well. So we've done a fair bit of that sort of stuff, but not primarily satellite based. Okay. SHALE2, we've got involved in support of the German and Qatari colleagues to try and look at how we might best use this. TV has a multitude of digital standards. There are 2 standards, 4 types of modulation. You can then set 11 error correction settings. You can infinitely vary the symbol rate, and you can use 3 encoders. Apart from that, it's standard. And of course, we can do 2-way QSOs of broadcasts. We're talking about bandwidths anywhere between 500 kilohertz up to 8 megs. Out of interest, we do digital ATV on the 146 meg band, just above the normal 2 meter allocation, using 500 kilohertz bandwidth. And that's going quite well. Most of our current equipment only supports the older standard of DVBS. I'll come back to that. I've given you loads of modes there. This graph, it's a bit of an eye chart. Upwards is spectral efficiency, so low efficiency down, high efficiency up. Left, right, carrier to noise. So over the left-hand side there, minus 3 dB carrier to noise. If you use DBS2 QPSK, you can dig a signal out when it's 2 dB below the noise. If you use DVBS, that we currently use for most of our terrestrial work, you can get a signal out from 3 dB above the noise. If you use 8 PSK, which is proposed for the beacon, currently, you need 6 to 7 dB. So we can play tunes on that. The amount of error correction you use, the type of modulation you use, there's massive potential for experimentation here, and we're really looking forward to that. However, we do need to coordinate. I think most people are going to end up starting with the current terrestrial gear, using DVBS, QPSK, either at 2 or 4 megasymbols. Now, 2 megasymbols comes out to be about 2.5 megs wide in the transponder. So we could easily fit 3 of those in our transponder. Our receivers need to know the basic info. It needs to be programmed into them. It's worse than programming your VCR, I warn you. We're working on a tool to enable coordination of this, and also to do spectrum monitoring. This is what we're looking at. There's a demonstration of this in the other room, live demonstration. And this screenshot was taken from that a couple of hours ago. Quite simple, spectrum analyzer display there, looking at the whole 8 megs bandwidth. And you can see there are 2 TV signals in that bandwidth. Or are there 6? Well, actually, there's 2 there. There's one on the left that's a really nice shape, looks like a good haircut. And there's the one on the right that looks like when you would need to go to the barber's, which has got the big shoulders on. And people have been talking about shoulders that come up through nonlinearity. That's what they tend to look like. We'll also have on the right there a chat window. So this is all internet based, chat window, so you can say, what's that signal on the left? Oh, it's him, he's running QPSK, 2 megasymbols, 7/8 FEC. You can then put that into your satellite receiver and receive the transmission. Okay. Frequency plan. We've already seen one frequency plan this afternoon. We've yet to bash this out, the exact frequency plan. Needless to say, it's going to have to be flexible to support the experimentation. And we can vary it from one day to the next. Right, how do we receive it? Well, there's been a lot of good stuff about that already. 80 centimetre dish in the UK we think will be good for TV. Low noise blocks. This is the Octagon LNB. It's about £25 on eBay. It uses a phase lock loop local oscillator on 9750. That will be quite adequate. However, it's a standard Sky LNB, a universal LNB. It puts the IF signal outside of a standard set-top box, puts it at 741. Standard set-top box cuts off at 950. So we're going to need to do something about that. There are 3 possible solutions. We can move the local oscillator in the LNB. There are a number of LNBs available with a 9 gig local oscillator. They just changed the DRO puck in there to move the oscillator down. Those modified LNBs, once they've been modified, tend to drift in temperature. I've got one up on the outside of my house. It drifts about 1 meg when it goes into the sun. So it's not really ideal. You can use a wider frequency range tuner. There are some of the tuners that are out there will tune down to about 600 megs, which will be fine for our purposes. Of course, that needs special receiver software or special software to drive them. These are the tuners in question. Those ones there, that's a little sharp tuner. They're available from the BATC shop because we use them a lot. I've sold about 100 of those tuners already. And there is a USB tuner card here that then plugs into your computer and enables you to get the TV pictures on your computer and set any parameters. Nice little tuner, goes from about 600 to about 2400 megs in one. Really nice piece of kit. The third option is you can upconvert. One way we do that, we can use something we call a SUP 2400. They're sold in the USA to enable this sort of thing to be done for commercial satellite receivers. They're about they're £5 today from the BATC shop, or £7.50 with postage, I believe. Really cheap, really good solution. They're nice and stable. They're phase locked. Last option, David G0MRF is showing a down converter for 144 megs in the other room. We believe that if you up convert, it's got about a 600 meg LO, that'll take the signal up to about 1350 straight into the passband. Not tested yet, but we think that's going to be another option for you. So you can use the same receive kit as you're using for your narrowband, downward for 144, you can go up to 1350. At the same time, yeah. That's a USB receiver that I've just shown you. And if you want to see the software running on the PC that receives the pictures, again, we've got one in the demo. Transmission, a lot more complex. These are all the elements we think we need. You start off with video, either digital or analog. Compress it, put in a transport stream, put in some error correction, split it into I and Q, filter it, modulate it, and then put it into a very linear amplifier. And there is the biggest problem. Of course, we're in the Wi-Fi band. I'm not really sure how my home Wi-Fi router is going to react to 100 watts of 2.4 gigs flying around. Hence, I bought one that does 5.6 gig Wi-Fi. There may be some problems in some countries with licensing. Spectral regrowth, though, is the biggest issue. We'll come back to spectral regrowth in a minute. How do you generate the signal? Well, a lot of us have got DATV transmitters that already generate at 437. And we've got transverters that will go to 2320 or 2400 megs. That's a possible solution. And we can modulate this, produce the original signal from something like the DTX1, which is here. This is a commercial product that we've had modified for amateur TV use. Again, available from the BATC shop. Video in, RF out, really simple. DigiLite, which is a homebrew solution, drawn up by some BATC members about 4 years ago, but a bit old hat these days. And DATV Express, which is a nice FPGA software-defined transmitter. We'll come back to that as well. If you want to up convert, you can use your narrowband converter, or can also sell an up converter. I'm not sure what the cost is. Second option is you can generate the signal directly at 2400. You can use the DATV Express, which will actually output directly at 2400 megs. DigiLite can be made to do it. DTX1, we're hoping to get a modified version that will do it very soon. However, all those solutions are low power. We're talking about somewhere between 0 and 10 dBm out of them. That's what the inside of a DTX1 looks like. Very nice piece of engineering. We need to get up to 50 or 100 watts. Now, we've just seen that block flying around the room. Very nice. I reckon maybe get 30 watts of clean DATV out of that. Probably not much more. For transmissions on 146 megs, we are using 80 watt PAs to get 5 or 6 watts out, to get it clean enough on 146. And portable, that's draining batteries at quite a rate. This is what I mean by spectral regrowth. On the left-hand side there is an excellent example. I think this is Knowles' 146 meg DATV transmitter, about 55 dB down. On the right-hand side is something I was playing with in the shack and put in the bin. About 20 dB, the shoulders are down there, totally unacceptable. What are we going to achieve? Probably about 30, 35 dB. That's where we need to be. But it's a big problem. I talked about DVBS, DBS2, the various options. All the transmit options I've been talking about at the moment are DVBS, QPSK. If we want to get into DVBS2, the options are more limited. DATV Express, the hardware will do it, but you need Charles Brain's experimental software and Linux, which works very well, but it's not yet in released, I believe. I know he's watching on the stream. He's done a really good job with it. The SR Systems kit will also, I believe, produce DVBS2. On receive, you are going to need to use a domestic set-top box with some sort of converter to put the signal into the passband. So your normal set-top box that's under your TV, not a Skybox, unfortunately, and one of these. The Skybox won't go down low enough in symbol rate for us. So, just about on time. I see it as a fantastic opportunity for experimentation. You know, I've been playing with satellite downlinks for many years. It'd be great to play with the uplink. Ground stations need to be flexible, and we're going to need to manage this bandwidth and be good neighbours. Getting that transmit capability with getting it clean enough, not wiping everybody's Wi-Fi out, staying married is going to be a real challenge. And we've got to coordinate. But let's start simple. Let's get receivers working. Let's look at the beacon. Hopefully we can get enough stations onto this thing such that we don't need the beacon anymore. That, I think, should be our aim. Thank you very much.
Good, thank you. David, thank you very much indeed. Any questions?
Cheers, Jim. One question. The figures you quoted for how much power we need to get out, was that for full HD or for SD, or what, as far as bandwidth goes?
The figures we've been given are for the full transponder.
Okay.
So we're talking about 100 watts into a 2.4 meter dish, which gives 50 dB watts EIRP for all 8 megs. Right. Certainly what I'm going to start doing, because I'm not going to have that power available, I'm going to use reduced bandwidth TV, where I only use 500 kilohertz of the transponder. So I'm going to be down at a 16th of the power. So I can then probably get in, I hope, with about 10 watts. And that's the sort of experimentation and we want to do, and then start playing with the different modulation schemes so we can achieve pictures with less carrier to noise.
Okay, thank you. Any other questions?
Chris, oh, sorry. Murray.
You might want to follow up on the... Yeah, just to follow up, and I'm sure you'll comment on it, if you take the bandwidth down, some of the commercial set-top boxes can't obviously decode at the very low rates, which you might want to caution people on. Yeah,
the most set-top boxes won't decode anything below 1 megasymbol. So reduced bandwidth TV, you're going to need to use a specialized receive solution, such as the mini tuner with TuTune software. Good point. Thanks, Murray. Chris.
So you mentioned the skyboxes. Obviously don't necessarily meet all of the requirements just right now. But if I had one, is it worth me throwing my one away, or should I be waiting for X amount of years? No, throw it away now? Okay, you got it.
The lowest bandwidth, lowest symbol rate a skybox will go for is 10 megasymbols, which is... Mike.
Thanks. What about software for the receive side? Because I know that we can already do DVBS with software. Is it going to be possible to do DVBS2 in a reasonable amount of time?
Jean-Pierre F0DZP, who wrote our current software, is thinking about it. And I'm not sure many other people have got the depth of knowledge to write that software, because there are so many registers that need writing to and reading from in this little tuner. Yeah.
Any other questions? Okay, David, we'll let you off.
Thank you very much.
Thank you very much indeed.